Robots, written by Lisa Ng. Robots. Table of contents. What are robots? Tireless workers, dangerous situations, robot explorers, mechanical animals, robot intelligence, conclusion, glossary, index. C-3PO and R2-D2 from Star Wars are far more advanced than real robots. What are robots? You may think of robots as the human-like machines you've seen in movies, television, shows, and books. But in real life, robots aren't as advanced as R2-D2 from Star Wars. Most robots cannot imitate humans or think for themselves. However, real robots can do many interesting things. They can perform dangerous tasks such as exploring active volcanoes, visiting distant planets, and defusing bombs. They can also do more common tasks such as building cars and playing chess. Perhaps one day people will be able to build robots as smart as humans. Robots are machines with mechanical bodies, information sensors, and computer brains. Most robots can move or have moving parts. Many robots can also use devices like video cameras and microphones to act as their eyes and ears to gather information from the world around them. Robots are programmed to perform certain tasks, either independently or by remote control. The program plans every step of the robot's job in painstaking detail. Most robots cannot do anything that they have not been programmed to do. This robotic vehicle, seen going over an obstacle, has parts that include an arm, camera, wheels, computer brain, and antenna. Simple robots can perform simple tasks such as moving car parts on an assembly line. For this job, the robot only needs one arm, a sensor that tells it where the parts are, and a program that governs lifting the part and putting it down in the right place. As robots get more complex, more programs have to be packed into their computer brains. It's much easier to build 10 robots to do 10 different things than it is to build one robot to do those 10 things. Therefore, robots tend to be specialized for the tasks they perform. A huge robot arm looks very different from a small explorer robot, and they could not do each other's job. A complex rover robot. This simple robot arm helps make solar cells. Tireless workers. Imagine working at a job picking up nails and putting them into boxes as they pass through an assembly line. Imagine that this is the only thing you do all day and night, and you never get to take breaks to eat, sleep, or go to the bathroom. No human being wants to do this job. Within a few minutes you'd be bored and unable to focus. After a while you'd be tired, cranky, and exhausted. But robots do this job perfectly every time without complaining. The word robot comes from the Czech word robota, which means forced labor, or hard, boring work. In fact, most robots in operation today are factory robots. Many are simple robot arms of varying designs. Some can grip pieces of metal, while others weld them together, and still others drill or spray paint parts. Robot arms with a lighter touch can sort items such as chocolates and tiny screws. Robots have replaced workers on many assembly lines. Dangerous situations. Robots can go places that are too dangerous for humans. After an accident at a nuclear power plant in 1979, officials sent in robots to evaluate the damage and help clean up. The radiation from the nuclear accident could have killed any living creature. Nuclear plants currently in operation use remote-controlled robots to move radioactive equipment and conduct inspections. Some robots can locate and defuse bombs and landmines. In addition to being much more precise and sensitive than human experts, these robots are also replaceable if the bombs explode. Other robots actually are bombs. These robots, called smart missiles or smart bombs, contain sensors that detect the target and battery-run computers that control the flight path. A bomb disposal robot. Robot explorers. Robots that are built to explore are particularly advanced and interesting. Dante 2 is an 8-legged crawler robot built to get superheated gas samples from inside Mount Spur, an Alaskan volcano. It was damaged during its mission, but Dante 2 successfully obtained its samples. The year before, 8 scientists died trying to get samples of the volcanic gases. The remote-controlled Nomad robot explored the Atacama Desert in Chile, traveling 214 kilometers or 133 miles in 45 days while collecting rock and soil samples. The Atacama Desert is similar to the terrain on the Moon and Mars. Nomad even explored icy Antarctica. The Nomad robot was designed to explore Antarctica. Scientists test Opportunity's ability to drive over obstacles. The Spirit and Opportunity robots explored the surface of Mars in 2004. These identical robots were programmed to act as geologists or scientists who study rocks. They were equipped with tiny rock drills, microscopes, and instruments that can tell what rocks are made of. Scientists controlled these robots by sending radio signals over 78 million kilometers, 48 million miles, through space. Robots don't need food, water, or air. They don't age or get bored. They don't even need a return trip home. For these reasons, much future space exploration will involve robots rather than people. Mechanical animals. People have tried to build human-like robots for decades. The problem is that it's hard for robots to imitate human versatility or the ability to do many things. In fact, the more automatic a task is for a human, the harder it is to program a robot to do it. Every person learned to walk, but after that, we do it by instinct. It's hard to program top-down processing, where robots have big, complex programs that control many different movements and processes. Scientists have developed robot animals that use bottom-up processing. This means a scientist program a robot to perform only one very simple task, such as rolling or walking on many legs. Then the scientists add more simple programs one by one. This idea began with robots that imitate insects. These tiny bug bots move and react just like insects and can send signals to each other. This robot acts much like an insect. This solar-powered robot fish is one of many toys built to look like sea animals. Toy makers have also created robots that look and move like shrimp, crabs, and jellyfish. Some scientists have developed robot animals as a way to research the way real animals act. Robo-Tuna, Wanda, and Rudolph are robots that recreate the way fish swim and dolphins use sonar. Several companies have manufactured robot dogs as expensive toys and companions. These dogs bark, move, and perform tricks. More advanced models can recognize their owner's voice and respond with actions or flashing lights. Robot intelligence. The computer Deep Blue faced off against Grandmasters chess player Garry Kasparov in a 6-game series. Even though Deep Blue could calculate up to 100 million moves per second, Kasparov won. A year later, Deep Blue and Kasparov faced each other again. Before the rematch, Deep Blue was improved so that it was twice as fast. This time, the computer beat the world's best human chess player. Garry Kasparov loses to Deep Blue in 1997. This is pretty amazing, but Deep Blue isn't really smarter than Garry Kasparov. Deep Blue does not think at all. It looks through its database of possible chess moves. Then it calculates which move or strategy has the best mathematical chance of winning the current game. So in a sense, Deep Blue is something like an extremely powerful calculator. It does not think. And Deep Blue can only play chess, while Garry Kasparov can walk, talk, write, and do all the other things that humans do. True artificial intelligence, or AI, involves human-level intelligence. It involves the ability to learn, react to new information, and make decisions independently. Scientists are still working on creating computers and robots with real AI. Do you know? The Turing test measures whether a computer is intelligent enough to appear human. A judge communicates with a human and a computer at the same time. If the judge cannot tell the difference, the computer and the scientist behind it wins. To beat this test and to react to the billions and billions of possible questions a human judge could ask, a computer has to be truly intelligent. Can you tell the robot from the person? Conclusion. All of us depend on robots, but few people ever see the robots that keep our lives running. In the future, we might see robots that clean house, mow lawns, and respond to voice commands. But even the best robots will never be able to replace people. Humans are creative and adaptable, and even the most advanced robots are not. Do you know? There might be a robot in your family's car. Some windshield wipers turn on automatically when it begins to rain. The wipers have sensors and computers that turn the wipers on and off. These wipers are robot arms. Glossary. Artificial intelligence. A computer program that can make decisions, respond, and think. Page 14. Bottom-up processing. Programming that combines small, simple programs into a whole. Page 11. Diffusing. Taking an explosive device apart so that it doesn't blow up. Page 4. Geologist. Scientists who study the structure, physical makeup, and history of Earth. Page 10. Labor. Difficult physical work. Page 7. Obtained. Gain control or ownership. Page 9. Painstaking. Taking a lot of detailed effort and thought. Page 5. Radiation. A dangerous form of energy that can cause burn, sickness, and death. Page 8. Radioactive. Giving off radiation. Page 8. Specialized. Made to perform just one task. Page 6. Top-down processing. Programming that puts one complicated intelligence or thought process in charge of all other processes. Page 11. Versatility. The ability to do many different things. Page 11. Index. Artificial Intelligence, Dante 2, Deep Blue, Gary Kasparov, Nomad, Opportunity, R2D2, Spirit.